right then. Okay, so write a program that reads two integers from the standard input and print the result of dividing the first number. Okay, revise your program to throw an exception if the second number is 0. Test your program with a 0 input to see what happens on your system if you don't catch. Okay, so this will be interesting. This is section section 5.6.3, right? Right. Okay, so I want to, I'll start with exercise 5.24. Okay, so we will start with 5.24. Stream. Okay, so revise an input to throw an exception if the revise the program from the previous to use a to throw an exception. Okay, let's see. Int a equals to 2, b equals to 0, and I'll go if b equals b, then we can say throw. How do we throw an exception? We'll go with throw dot. I think, yeah, throw runtime error. Throw. I think there were more. Yeah. Okay, throw the most general kind of exception. The exception header defines. Okay, so we'll include exception. We'll go through exception plus. Okay, runtime. No, is it throw new exception? I don't know. Okay, so I'll just write a runtime error and instead accept. Okay, instead accept. I think this should be a runtime error trying to divide by 0. Okay. So we'll run this program and runs terminate. Okay, so it says what? Trying to divide by 0, terminate quarter, right? So the terminate function gets called. Okay. Then we have revise the program from the previous exercise to use a try block to catch the exception. The catch clause should print a message to the user and ask them to supply a new number and repeat side. Okay, so we can catch an exception with runtime error. Okay, so 5.25, I think. 5.25, right? Okay, so 5.25. So okay, I say int a equals 0, b equals 0. Then I can say, yeah, do enter two numbers, right? Then we can see in we can see in a and b. I can say if b, okay, and all of this is to be done in a try block. Okay, this is to be done in a try block, and I will catch runtime error. Okay. Then operation. Oh, okay. My bad. This should come here. Catch, and this comes here. Yep. Okay. So if b 0 equals 2, we can say throw operation failed, and we can say error dot what. Z and L. We can say try again, right? Try again. Throw runtime error. Search runtime error. Right. Yeah. Throw a runtime error, and we'll say trying to divide by 0. 0, and we can say while cn, right? Okay. Expected. Okay, my bad. Right, so it asks for two numbers, and say 5 and 2, but okay, 2 and 0. Operation failed, trying to divide by 0. Okay. 6 and 5, 0 and 0. Okay. Right. Says operation failed. Runtime error. Okay. Doesn't really matter. Okay, try again. Saying try. Okay, how did use? Okay, so it reads a char, right? There, try again, yes or no. Let's say try again, then I can take in a value. See, see, see. Then we'll say try again. Y n c equals n. Then we break out of the loop. Right. Okay. Do two numbers 5 and 0. Try again. Yes. Right. Now this is complete. But I'm not. Okay. So now we move on to say calls the terminate function. With the given message. Okay, now we are going to move on to chapter 6 functions. Okay, so this chapter this chapter describes how to define and declare functions. We'll cover how we'll cover how arguments are passed to and values returned from functions. In C++, functions can be overloaded, which means that we can use the same name for several different functions. We'll cover both how to overload functions and how the compiler selects the matching version for a particular call from several overloaded functions. The chapter closes by describing pointers to functions. A function is a block of code with a name. We execute the code by calling this function. A function may take 0 or a function may take 0 or more arguments and usually yields a result. Functions can be overloaded, meaning that the same name may refer to several different functions. Okay, function basics. A function definition typically consists of a return type, a name, a list of 0 or more parameters, and a body. Right. The parameters are specified in comma-separated list enclosed in parentheses. The actions that the function performs are specified in a statement block referred to as the function body. Right. Okay. We execute a function through the call operator. We execute the function through the call operator, which is a pair of parentheses. The call operator takes an expression that is a function or points to a function. Inside the parentheses is a comma separated list of arguments. The arguments are used to initialize the function's parameters. Type The type of a call expression is the return type of the function. Right. Okay, the type of a call expression is the return type. Writing a function. An example, we write a function to determine the factorial of a given number. The factorial of a number is n in okay. The factorial of a number n is a of product of the numbers from n through 1 through n. The factorial 5 for example is 120. We might define this function as a value as follows: value minus 1 to 1. Okay, so we write the local variable to hold the result as we calculate it, then value minus. Okay, assign return times value to return and decrement value. Right. Okay, our function is named fact. It takes one integer parameter and returns an int value. Inside the while loop, we compute the factorial using the postfix decrement operator to reduce the value of val by 1 on each iteration. The return statement ends execution of fact and returns the ret value. Okay, calling a function. To call fact, we must supply an int value. The result of a call is also an int. Right. Okay, a function call does two things. It initializes the function's parameters from the corresponding arguments, and it transfers control to that function. The execution of the calling function is suspended and execution of the called function begins. Execution of a function begins with the implicit definition and initialization of its parameters. Thus, when we call fact, the first thing that happens is that an int variable named val is created. This variable is initialized by the argument in the call to fact, which in this case is 5. Okay. Execution of a function ends when a return statement is encountered. Like a function call, the return statement does two things. It returns the value, if any, in the return, and it transfers control out of the called function back to the calling function. Okay. The execution of a function ends when a return statement is encountered. Like a function call, the return statement does two things. It returns the value, if any, in the return, and it transfers control out of the called function back to the calling function. The value returned by the function is used to initialize. The value returned by the function is used to initialize the result of the call expression. Execution continues with whatever remains of the expression in which the call appeared. Okay. Thus, a call to fact is equivalent of the following: int val is set to 5. Goes with it. Okay. So, parameters and arguments. Okay. Arguments are the initializers of a function's parameters. Right. Okay, the first argument initializes the first parameter, the second argument initializes the second parameter, and so on. Although we know which argument initializes which parameter, we have no guarantee about the order in which. Right. Okay. Although we know which argument initializes which parameter, we have no guarantee about the order in which arguments are evaluated. The compiler is free to evaluate the arguments in whatever order it prefers. Okay. The fact the type of each argument must okay, the type of each argument must match the corresponding parameter in the same way that the type of any initializer must match the type of the object it initializes. We must pass exactly the same number of arguments as the function has parameters. Okay, we must pass exactly the same number of arguments as the function has parameters, because every call is guaranteed to pass as many arguments as the function has parameters. Parameters are always initialized. Because fact has a single parameter of type int, every time we call it, it must supply an argument that can be converted to int. The first call fails because there is no conversion from const char to int. Const char pointer to a const char. Okay. The second and third call. Okay. The second and third call passes. Okay. The second and third call passes the wrong number of arguments. The fact function must be called with one argument. It is an error to call it with any other number. The last call is legal because there is a conversion from double to int. In this call, the argument is implicitly converted to int through truncation. After the conversion, this call is equivalent to fact of 3. Okay. Right. Arguments are initializers for a function's parameter. Okay. Functions parameter list. Okay, a function's parameter list can be empty but cannot be omitted. Typically, we define a function with no parameters by writing an empty parameter list. For compatibility with C, we can also use the keyword void to indicate there are no parameters. Okay. A parameter list typically consists of a comma-separated list of parameters, each of which looks like a declaration with a single declarator. Even when the types of two parameters are the same, the type must be repeated. Okay, no two parameters can have the same name. Moreover, local variables at the outermost scope of the function may not use the same name as any parameter. Local variables at the outermost scope of the function what does this mean? Okay, parameter names are optional. So we have no two parameters can have the same name. Moreover, local variables at the outermost scope of function may not use the same name as any parameter. Okay, let's give it a try. Let's see what happens. If I'm understanding it correct, okay, so it says that moreover local variables at the outermost scope of the function which means local variable at the outer. Okay, what is outermost scope? I think you mean within the function we cannot define the same, right? I think this would mean that. I don't know. So we'll create a one, scope of function parameter. Okay, function parameter. I just do function parameters. Okay. Okay, so you mean to say if I say hi and I say int a, then I cannot define int a, right? I think this would, and I think this is what it means, which should be, because there are multiple uh, declarations, multiple definitions, because it is defined. Say hi, say 50. Yeah. Okay, error. Declaration of int a shadows a parameter. Okay. Mm. Yeah, I should just copy this. However, there is no way to use an unnamed parameter, therefore, parameters ordinarily have names. Okay. Occasionally, a function has a parameter that is not used. Such parameters are often left unnamed to indicate that they aren't used. Okay. Leaving a parameter unnamed doesn't change the number of arguments that a call must supply. A call must supply an argument for every parameter if the parameter, even if that parameter is not used. Okay. Function return type. Most function can be used as a return type. Most types can be used as a return type of a function. In particular, the return type can be void, which means that the function does not return a value. However, the return type may not be an array type or a function type. Okay. However, a function may return a pointer to an array or a function. Okay. We'll see how to define functions that returns pointers or references to arrays. And here, okay. Local objects. In C++, names have scope and objects have lifetimes. It is important to understand both of these concepts. The scope of a name is the part of the program's text in which that name is visible. Okay. The lifetime of an object is a time during the program's execution that the program exists. As we have seen, the body of a function is a statement block. As usual, a block forms a new scope in which we can define variables. Parameters and variables defined inside a function body are referred to as local variables. They are local to that function and hide declarations of the same name made in an outer scope. So what is the difference between a parameter and an argument? So we'll say, I think I should complete this. Okay, objects defined outside any function exist throughout the program's execution. Such objects are created when the program starts and are not destroyed until the program ends. The lifetime of a local variable depends on how it is defined. Okay, important point because it can be a local static or a local. Yeah, okay. So, what is the difference between a parameter and an argument? Okay, arguments are initializer, initializers, initializers to parameters. Okay. Indicate which of the following functions are in error and why. Okay. So yeah, mismatch in return type. No return type. No return type. Okay, int calc, int v1. Okay, same, same name parameters cannot exist. Okay. Return double square. Uh, a block is necessary, right? Because function calling a function. Okay, so function, the actions that function performs are specified in a statement block. Refresh. Boom. Why did I do that? Okay, no. Okay. Statement. Okay. Statement. Emphasis on the statement block. Okay. Block is necessary. Okay. Automatic objects. The objects that correspond to ordinary local variables are created when the function's control path passes through the variable's definition. Like the objects that correspond to ordinary local variables are created when the function's control path passes through the variable's definition. They are destroyed when control passes through the end of the block in which the variable is defined. Objects that exist only while a block is executing are known as automatic objects. After execution, after execution exits, after execution exits, a block okay, after execution exits a block, the value of the automatic object created in that block are undefined. Parameters are automatic objects. Storage for the parameters is allocated when the function begins. Parameters are defined in the scope of the function body. Hence, they are destroyed when the function terminates. Automatic objects corresponding to the function's parameters are initialized by the arguments passed to the function. Okay. So, automatic objects corresponding to the function's parameters are initialized by the arguments passed to the function. Automatic objects corresponding to local variable are initialized if their definition contains an initializer. Okay. Full variable initialized. Otherwise, they are default initialized. which means that uninitialized local variables of built-in type have undefined values. Okay, then we have local static objects. It can be useful to have a local variable whose lifetime continues across calls to the function. We obtain such object by defining a local variable as static. Each local static object is initialized before the first time execution first before the first time execution passes through object's definition. Local statics are not destroyed when a function ends, they are destroyed when the program terminates. Okay. As a trivial example, here is a function that counts how many times it is called. Okay. So count calls, we have static size t. Okay. This program will print the numbers from 1 through 10 inclusive. Before control flows through the definition of CTR for the first time, CTR is created and given an initial value of 0. Okay. Each call increments CTR and returns its new value. Right, okay. Whenever count calls is executed, the variable CTR already exists and has whatever value was in that variable the last time the function exited. Thus on the second invocation, the variable of CTR is 1 and on the third it is 2. If a local static has no explicit initializer, it is value initialized, meaning local statics of built-in types are initialized to 0. Value initialized. Okay. So explain the differences between a parameter, a local variable, and a local static variable. Okay, so let's see. Give an example of a function in which each might be useful. Ooh, that. Okay. How can I have a function? Okay. Okay, let me tackle the first part. Right, okay. Parameters are local objects that are initialized at call, right? No, they are not initialized at call. Local object that are initialized using the values in the arguments, right? Yeah, okay. Okay, parameters are local objects that are initialized using the values in the arguments. Local variable, if not explicitly local objects, local variable. You can say, yeah, local objects mean the same. Local variable, if not explicitly initialized, the function body is default initialized, and local static variables are initialized before going through the function body, right? If local, it is value initialized before control flows through the definition of CTR for the first time. CTR is created and given an initial value. Okay. Okay. So in the definition, for initialized and local static variables are created before control flows through the definition of that variable. Okay. The scope of both the scope of parameters and local variables. Okay, the scope of parameters and local variables is up to the scope and I should say the scope and lifetime. No, only scope. Okay. The scope of the parameters and local variables is inside the function, inside the functions We're trying to come up with a function which uses local, which uses parameters, local, local static and local variable. Okay. Okay, great. Then we have write a function that returns 0 when it is called. It is first called and then generates numbers in sequence each time it is called. Again, okay. Sorry. 6.67. Nope. 6.7. Right? 6.7. Yes. Okay. Stream. And I don't need anything else really. Call function, right? I can have an static int count equals 0, and then we can return count plus plus. Okay. So I'll just write a loop less than, let's say 10, right? I plus. So we can print whatever call func returns. It should return numbers from 0 to 9. So okay, great. Okay, then we have function declarations. Like any other name, the name of a function must be declared before we can use it. Okay. As with variables, a function may be defined only once but may be declared multiple times. Okay, with one exception that we'll cover here. We can declare a function that is not defined so long as we never use that function. We can declare a function that is not defined so long as we never use that function. Okay. A function declaration is just like a function definition, except that the declaration has no body. In a declaration, a semicolon replaces the function body. Okay. Because a function declaration has no body, there is no need for parameter names. Hence, parameter names are often omitted in a declaration. Okay. Although parameter names are not required, they can be used to help users of the function understand what the function does. Okay, so parameter names chosen to indicate that the iterators denote a range of values to print. Right. These three elements, the return type, function name, and parameter types, describe the function's interface. They specify all the information we need to call the function. The function declarations are also known as the function prototype. Okay. Function declarations go in header files. Recall that variables are declared in header files and defined in source files. For the same reason, functions should be declared in the header file and defined in the source file. Okay. So we have, it may be tempting and would be legal to put a function declaration directly in each source file that uses the function. However, doing so is tedious and error prone. When we use header files for our function declarations, we can ensure that all declarations for a given function agree. Moreover, if the interface to the function changes, only the declaration has to be changed. Right. The source file that defines the function should include the header that contains the function's declaration. That way, the compiler will verify that the definition and declarations are consistent. Okay. So we have the header the header that declares a function should be included in the source file that defines that function. Okay, write a header file named chapter 6.h that contains declaration for the functions we wrote in exercise 6.1, page 205. Okay, here, exercise 6.1, all exercises 6.1. Okay, so separate compilations. Right, I think I should cover the 52. Okay, let's say. Okay, as our programs get more complicated, we'll want to store the we'll want to store the various parts of the program in separate files. For example, we might store the functions we wrote for the exercise in one file and store code uses uh, that and store code that uses these functions in other source files. To allow programs to be written in logical parts, C++ supports what is commonly known as separate compilation. Separate compilations let us split up programs into several files and each of which can be compiled independently. Okay, compiling and linking multiple source files. As an example, assume that the definition of our fact function is in a file named fact.cc and its declaration is in a header named chapter 6.h. A fact.cc file, like any file that uses these functions, will include the chapter 6.h header. We'll store a main function that calls fact in a second file named factmain.c. Okay, so we'll store a main function that calls fact in a second file. Okay, to produce an executable file, we must tell the compiler where to find all of the code we use. Okay, okay, so we might compile these files as below. Okay, cc generates executable, generates main or main.exe. Here cc is the name of a compiler, dollar is a system prompt, and begin hash is a command line comment. Okay, we can now run the executable file which will run our main function. If we have changed only one of our source files, we'd like to recompile only the file that's changed. Most compilers provide a way to separately compile each file. This process, okay. Okay, this process usually yields an object windows or .o file extension indicating that file contains object code. Okay, the compiler let us link object files together to form an executable. Okay, so we can separately compile fact this. Okay. You'll need to check with your compiler's user guide to understand how the compile and execute programs made up of argument passing. Okay, that is it for today.